order up to model, definitions, and implementation. In the order up to model, we will assume time is divided into periods such that we have exactly one order in every period and we receive one previously ordered quantity once every period. So the period can be sometimes 1 week or 1 day or 2 weeks, but remember it has to be defined in such a way that there is exactly one order submitted in a period and one order received in the period. And the timing of events that we will assume is the following. During each period, we will first submit an order request for another quantity if we need. So a special case could be that the order quantity is 0, and that means we really don't order anything. The second thing that will happen in the period will be that we receive a previously ordered quantity. And the third will be the demand occurs throughout the period. So the first two things will happen usually at the beginning of the period, and then the last will happen throughout the duration of the period. So the key measure to realize that decides a lot here is the lead time. Lead time, for which the symbol will be small l, is the fixed number of periods after which an order is received. And the limitation of this model is that actually L should be an integer number of periods. So to give you an idea, if I have a situation where I order once a week, then I have to set the period to 1 week. And because of this, I also have to have a lead time, which is a multiple of weeks, because lead time has to be an integer number of periods. So in this case, an integer number of weeks, right? And sometimes you might have a lead time of 2.5 weeks, and then that actually creates a difficulty in using the order up to model, right? But for example, if your lead time is 1 week, then L would be 1 if the period is 1 week. Now, suppose you order once per day. Every day you can submit an order. Then the period should be set to 1 day. Now, if the lead time is 1 week, then actually it will be not 1, it will be whatever number of days per week you're operating. Let's say if you work 7 days a week, then lead time 1 week would be actually L equal 7, because it's 7 periods where periods are 1 day. So we have to be careful how we define the period, and then remember that lead time is the number of periods, my multiple of periods, right? It's measured in the number of periods. So here is an example with lead time being 1 period and the timing of events. So for example, when you consider period number 2, what happens here is first we submit order quantity number 2, right? So at the beginning we order some units. Then we receive what we ordered in period 1, at the beginning of period 1, because there is a lead time of 1 period, right? So say lead time is 1 period. Then, right, in this case, in period 2, we should receive what we ordered in period 1, right? And then after we make an order and receive a previous order, demand for period 2 occurs, right? And so on. You can see actually the time. So every order is received 1 week later, and the sequence of events within the period is always the same. Make an order, receive a previously ordered quantity, and then the demand for that period occurs. So here are some definitions that will be important to understand what is happening in the order up to model. First, we will define on-hand inventory. On-hand inventory is the number of units that are physically in inventory that are ready to serve the demand. Back order is the second quantity. Back order is the total amount of demand that occurred but has not yet been satisfied. So the assumption we will make is that all demand will be satisfied. There won't be any lost demand. However, some of it may be satisfied not immediately with a delay because we experience a stockout. So back order, right, will happen only when on-hand inventory is 0 and additional demand occurs. In that case, right? Let's say if there is no inventory and I still have demand for 3 units, I will say my back order is now 3 units. The third type of basic inventory will be on-order inventory, also called pipeline. This is the number of units that have been ordered, but we haven't received them yet. And so, right, at the moment I order a quantity, let's say I order 5 units, then this 5 units becomes my on-order inventory. And if while I'm still waiting for the first order, maybe I order another quantity of 3 units, then my on-order inventory becomes 8 in total because I have one order for 5 and another for 3, a total of 8 units on order. Now, the two calculated measures will be defined as follows. Inventory level is the sum, or actually the difference, between on-hand inventory and back-order inventory. And the interesting thing is that very easy to see that both of those measures will never be zero. If you have on-hand inventory that is positive, right? So I have units, some physical units that I can serve demand with. I shouldn't have any back order, right? Because I would have served this demand of back order with those units that I have on hand, right? So if this is positive, let's say this is 4 units, then back order should be 0, and inventory level 4 means there is some on-hand inventory. So whenever inventory level is positive, it means there is on-hand inventory. Now, what happens when on-hand inventory becomes 0 and I have additional demand, then I record it as back order. So let's say if I have 3 units of back ordered, back ordered units, 3 units of demand that I saved as back ordered demand, then I will say inventory level will be 0 minus 3. So that means it will be minus 3. So if when inventory level is negative, we know this indicates how many units are back ordered. And just remember that back order is a positive value, but in inventory level, it is represented as a negative, negated value. And the last composite measure will be inventory position. Inventory position is actually taking inventory level that we defined earlier and adding to it the on-order inventory. So this is telling us how much we have on hand or on back order, and this is just adding what already has been ordered. So this is like an overall balance of inventory, but remember it actually combines 3 measures. Inventory positions combines what's on hand, what's back ordered, and also what is on order, what has been ordered and not received yet. And finally, our decision in the order up to model will be the order up to level, for which we will use symbol S. You can think about this order up to level as the maximum inventory position that we allow, and this will be used to decide each order quantity. And you can some books or some presentations call this order up to level a base stock level. Sometimes the model order up to model is also called base stock model. So the order up to model will be implemented with the following simple rule. We will say that each period's order quantity, how much we order in each period, will be S, the order up to level that we define as a parameter of our model, minus the inventory position. So let's just consider examples to understand this simple implementation rule. Suppose S is 5. So that maximum inventory position that we want to have ever is 5 units. And suppose that we begin with inventory position equal to 2, right, in the period. In that case, we have to make an order at the beginning of the period that is S minus inventory position. In this case, S is 5 and inventory position is 2, so we should order 3 units, right? Why is inventory position 2? Well, remember, it is inventory level plus on order inventory, right? So this is it's aggregating all our information about on hand, back order, and on order inventory. Now, if a period begins with inventory position minus 3, right? Why could it be minus 3? Well, it could be minus 3 because maybe we have some units on back order. Maybe we have 3 units on back order and nothing is being shipped, or maybe we have more than 3 units on back order, but some things are on order and the balance is minus 3. In that case, we say we should order S minus inventory position, which is 5 minus negative 3. The inventory position is now negative. So we should order 8 units, right? So one thing to observe is that immediately after we order, inventory position becomes S, right? So why is that? Because remember, when you order these 8 units become an on order, or these 3 units, they become on order, an additional on order inventory. You order 3 units, your on order inventory is increasing by 3. And because of this, right, the inventory position becomes old inventory position plus the new on order inventory becomes 5, or S in those examples that we had, right? So this, we had inventory position minus 3. We have a new order for 8 units. So this becomes added, right? It's counted in the new inventory position. So that's why inventory position becomes 5. So after you order, inventory position becomes S. And an additional note is that in each period, the quantity you order will be equal to the demand in the previous period. And to see this, again, notice that after the order is made, inventory position becomes S, as we said in the previous point, right? Immediately after the order is made, the inventory position is S. Then, during the period, the demand occurs, right? So if the demand in the period is X, at the end of the period, right, inventory position decreases from S to S minus X, right? Because we just used up some, either on-hand inventory has been used, or maybe some units were put on back order. In any case, remember, demand is not lost, so the inventory position, one way or another, will be reduced by X. So at the beginning of the next period, when we order S minus inventory position, it will be S minus the inventory position that it was decreased from S by X. It will be S minus X. If you calculate the balance of this, right, S gets removed and all you get is X, right? So the next the next order is equal to the last demand from this, right? So from this analysis, what we can see is that order up to model is a kind of pull system. If you recall, pull system is a system where units are procured in response to demand. And in this case, you see, when we sell X units, or we have demand for X units, we order X units, right? So this is a kind of pull system because we order exactly the amount that we experience the demand for, and in this sense, inventory serves just as a decoupling buffer in a sense, right? However, S is of course set based on the forecast of the demand. So how much, what is the order up to level will be decided based on the forecasted demand.